Hi guys, this is the video how to create the application. This is Detector, which is that we can detect the disease on your skin, hand, and face. So if you take a picture, the result shows up on the upper side. For this case, I'm planning to use Tensorflow API and Tensorflow Keras API. Basically, to make this application, you might as well make use of one of two methods. I will explain about those methods one by one. This is the folder that saves image. I have 46 folders, and now for the first video, I convert this image to the TensorFlow record file and also NumPy MPY file and picker file. If you don't have time, you can just make use of one of them to convert the image. Even if you have only one file of them, it works well though. The reason why I would like to explain a couple of methods is that when you have any circumstance to use the image, you can choose one of them. After making a file, you can embed this file to the model. Here are two models, TensorFlow API model and TensorFlow Keras API model. I write down the code for the same way. If you embed this image on the TensorFlow API model, you can take CKPT file and PBText file. Likewise, if you put the image to Keras API model, you can also take PB file and convert it to the TensorFlow Lite file to use this model on the application. Since having a model, we can create iOS application and Android application on Google Play and iOS. So I will explain how to create all stuff one by one. First of all, you can get the sample image on GitHub. Below the YouTube, there is a hyperlink, so you can click it and take it. If you don't know how to get it, you can just simply go in the website and click the clone and download and click the icon. And then open the terminal and cd desktop to go in the desktop folder and write down git clone and paste it on the terminal. If you open the folder, there is the tutorial. So you can go in the tutorial and there is the requirement text. So if you have pip install and R and requirement text, you can download the package. Now I'm gonna convert the image with the MPY file, picker file, and TensorFlow record file. So I can explain about those one by one. So you can create the folder, tutorial folder on the desktop and open it and paste the image file here. So in the disease photos, there are arm, foot, and hand. Arm has each picture, and also hand has like picture, and foot also has the picture. Now just simply open Sublime or Python if you have, and I'm gonna create TensorFlow record file and also create the NumPy file and also create the picker file. You can simply open the file and to create the TensorFlow file, and you can go in desktop, tutorial, and we can create TensorFlow.py. Also, you can save it, MPI file, and also picker file. So mpy.py, and also create picker file, and then picker.py, pk.py. So we can separate it into two groups, tensor record, and mpy. So we can import TensorFlow as TF and also import NumPy as MP. So what I'm gonna do is that I can use same path, same image, and same folder. So we can compare TensorFlow record with NumPy. So to get the folder and image or path, we can just use import path library and also import OS. So also we can save it and paste it on NumPy. So we need two things, image and folder. So first one, to get the path of folder, we can write down data direction path library dot path os path join os dot get cwd and folder name. So simply we can check folder name. We can go in the folder and there is this is photos. So copy it and we can simply just paste it there. And then we can print one time. So os get cwd and data deal, you can print it, and on the terminal we can use Python and TensorFlow record.py. So first one is the os deal and second one is data deal. If we use os get cwd, we can get the current path. So if we use also join, we can combine both of them. So current path plus this is photo. That's why on the terminal. For the same way, we can get the data direction on NumPy. So to get the path of folder, simply we can save it and paste it here. And direction equal to this is photo. And then we can call it os path join and os get cwd and also data deal. So print data deal is same with the TensorFlow record, as you can see. After getting the path of folder inside the this is photo, there are three photos, arm, hand, and face. So we can get the name of folders. So each name of folder and label names equal sorted item dot name for item in datadeal dot group shop slash if item is direction. So simply print it, terminal Python TensorFlow record. We can get the direction, we can get the folder. Also we can get the each name of folder on NumPy. So we can write down categories and also folder name here. So we can simply check this is photos, food and face, food and face. And for category devices, we can put what you want, and category label names equal os path join data direction and which you chose, and then print label names. Python numpy. You can get the path of folder now. Actually, this code is on the website, so if you enter website, there's this code, so you don't need to write it down. But if you want to practice it, you can just simply follow it. So also you can get each name of folder plus number, and you can write down label to index equal dictionary and name index for index name in enumerate and label names, and simply we can print it. Python Tensorflow record. As you can see, there is number in front of the name. Also, we can do it in NumPy. So to get each name of folder plus number. So label to index equal category dot index category revise, which you chose. We can print label to index, so we can do it later. And also on the TensorFlow record dot TensorFlow record. So now we can get the path of image. So we need to get two things, path of folder and path of image, and this is number 4. And we can get our image path equal list data direction glob shop /shop and print our image path. So as you can see, we can see auto path, but there is POSIX path, we don't need it. So from now we can delete it. So we can write down our image path equal string path for path in our image path. Oh, this is path, and simply print our image path. Python TensorFlow record.py or a string. So str. So as you can see, there is not both path. So likewise, we can do it on NumPy. On this case, for image in OS list direction label names. So simply we can get the path of image, Python numpy.py. So this is the name of pictures. So now we can get each image plus number. Write down all image labels equal label index path library path and parent name for path in all image path. Simply print it. If we print it, we can see the number. So like 0, 1, 2. Arm is 0, hand is 1, face is 2, like this. So we can embed this label and path on the image dataset, TensorFlow data dataset from tensor slices, and all image path.map tf lead file. So when you read the image, we can use tf read file. So if we print it, as you can see, it holds the memory. So samely, we can do it on NumPy, import OpenCV and image array cv.imread and with path join and label name and image cv to imread color. If we print it, we can see the array of image. So we can put each image with number. So first of all, we can make the train data empty and train data dot append image array, which is array, and the index number. So label to index. If we print it, then first of all we can check the number of train data. So print len train data. As you can see, 177. Finally, we can save TensorFlow record. So we can import one thing, TensorFlow enable eager execution blanket, and TensorFlow record equal TensorFlow data experiment dot TensorFlow record writer and the name TensorFlow record dot TensorFlow record, and then TensorFlow record dot write and image dataset, and then we can simply run it. And there is not TensorFlow record file yet. If we run it, this one must be startup, so we can copy it and paste it upside, and then run it. And as you can see, we can see TensorFlow record file. The volume is 13 megabyte about, and on the NumPy also we can save NumPy file. It's simple mp dot save numpy dot mpy dataset, and then we can simply run it. Before that, we can make TensorFlow data to be MP array. So TensorFlow data, and then simply run it. As you can see, we have the NumPy, but the volume is much higher, 432 megabyte. Compared with that, 13 megabyte. And also pickle, we can use it. So just it's really similar with NumPy, so we can just copy it and paste it, and we can change only this one. So save pickle file. Now simply write down pickle out equal open pickle and write, so wb and pickle dot dump train data and pickle out, and also pickle closed here, and simply run it. Python and pk.py. We need to import it, so we can import pickle again. We get it. So next time we can embed this TensorFlow record file and mpy file and also pick a file on the models. As you can see, here are two models, TensorFlow API model and Keras API model. And then we can make an application to detect the name of disease. If you have a question, let me know it below the YouTube. I can apply within an hour. If you subscribe, I'll bring more useful information. I appreciate your time to watch it.